Hello, welcome to the continuation of the tutorial presented by the SHRDV. Now we are going to continue with the curve sketching. Okay, so curve sketching of quadratic functions. Okay, before we start drawing the curves, we are required to know that number one, to draw a curve, we can draw the curve by a normal way. It's a normal way for us to draw a curve by using the table of values. In the table of value method, we have a certain x, you have f prime of x, and we have f of x you find. You find a certain domain of x where x can exist. Let's say x exists in negative and positive infinity. At negative infinity and positive infinity, you are trying to have the corresponding value of y here. So you're going to have corresponding value of y, and having corresponding value of y, you're going to use the f prime of x, the gradient, in order to know the direction in which they are going to change. So I can use this method in quadratic in order for us to find the quadratic curve, or I can use the other method, which is the method of quadratic functions. So the first method, I will not use it here. I will only use the second method. This first method is a typical method we always use for other curves, for most complex curves. So I'm going to use the quadratic function curve, which is much more easier for us to calculate, to find the curves involving quadratic functions. Now, anytime you want to draw a quadratic function by method number 2, you require the x and y-intercept. So the first thing here to ask yourself is x-intercept. The x-intercepts are the points which cut the curve at x equals to 0. The x-intercepts are the x-intercepts are the points of x, are the x points which cut the line y equals to 0. And the y-intercepts are the y points which cut the line x equals to 0. So this, we are required to find both of them. When you find also them, in the second thing to find will be the y-intercept. After the y-intercept, in the second method, we are required to find the third part that we have seen here, the symmetry of the curve. And the symmetry of the curve is known as x negative b all over 2a. After finding the symmetry of the curve, we find the last one, the maximum point, the maximum y point. The maximum y point will be given as 4ac minus b squared all over 4a. So all these are required for you to draw a curve. So let's work with our function we initially had. F of x equals to 2x cubed plus 5x plus 3. Let's draw this. So when we want to draw this curve, we start with the step number 1. Our first thing to do is to find for the x-intercept. So we define the x-intercept as being the x point which get the graph at y equals to 0. Those are the x-intercept. So we see at y equals to 0, let's find the value of x. Let's find x. Now we put it 2x cubed plus 5x plus 3 equals to 0. Because f of x at this line, y equals to 0, is going to be equals to 0. So let's do the first method, which is method of factorization here. So this is an application of factorization. If I multiply here, my first step in factorization, we initially said we multiply a times c is going to give you 6. Then you gather 6. Imagine two numbers which can add up to give this 5 and multiply again to give the same 6. The two numbers are 2 and 3. So we have 2x cubed plus 2x plus 3x plus 3 equals to 0. We'll involve with this. So it gives me 2x x into x plus 1 plus 1 into plus 3. I can factor out 3 here into x plus 1 equals to 0. Now, x plus 1 and x plus 1 here are both common. So I can have x plus 1 all into 2x plus 3 equals to 0. So it implies that x is equals to negative. So it implies that x plus 1 equals to 0 or 2x plus 3 equals to 0. So it implies that x is equals to negative 1 or x is equals to negative 3 all over 2. So these are the two x-intercepts. Now, so already on my curve, if I have to draw this, I can represent already this on my initial table I've shown you. The table I've shown you is in such case. Let me give you an overall view of the table. I know that this curve has no limit, no bounds in which they don't exist. This will always the domain of x here. You can use any value of x in the real numbers. So real numbers, x is an element of real numbers excluding no number. So the domain of x here will be from negative infinity to plus infinity. So what happens is that I can put negative infinity here and plus infinity here. Now let's find the other case. In order for me to draw this curve, the next thing I need to find is the y-intercept. Even though the y-intercept is not as too necessary here. The y-intercept is a y point where x is equal to where x is equals to 0. Now, when I substitute x equals to 0 there, so f of 0 will be giving me the y-intercept. So it will be equals to 2 into 0 plus 5 into 0 plus 3. So y-intercept is equals to 3. So I have 2 points already. I have the point negative 1, 0. First point. Second point is negative 3 over 2 and 0. And the third point on my curve will be x0 and y3. These are already 3 points I have. Now, the next thing in this step, we have I3. The third part is a symmetry. The symmetry is given as x negative b all over 2a. So our x here will be negative b negative 5 all over 2 into 2. So it gives me negative 5 all over 4. This is the x, the symmetry of the curve. Now, lastly, you have number 4, the maximum y point. The maximum y point is given as 4ac minus b squared all over 4a. Now, y is equals to 4 into a here is 2 into c here is 3 minus 5 squared all over 4 into 2. So y is equals to, I multiply, it gives me 8 into 3 minus 5 squared all over 8. So y is equals to 8 times 3, 24 minus 25 all over 8. It gives me 24 minus 25 negative 1 all over 8. So the next thing I can think is number 5. Number 5 step I didn't give you initially, but you require the fifth step for you to find the curve. And that fifth step is to ask yourself the question, if a is greater than 0 or a is less than 0. I see in this case that a is equals to 2. So it implies that a is greater than 0. So I see a minimum turning point. So it can give me an expectation of the graph. Now, you see that we have to draw a curve. So I see my values are ranging in the x zone in positive and negative side. And in the y zone, my values are ranging to 3. Here is mostly to negative side and this one to 3. So I have this like as such. So this is my y-axis and this is my x-axis. So let's say I have 1 year, 2 year, yes 1 year, 2 year, 3 year, 4 year, -1, -2, -3, -4, -5, -1, -2, -3, -4, -5. Now, I know that the first point, as we have seen here, -1, 0 is on the curve. So -1 is x component and 0 here. So this point is here. We have -3 all over 2. -3 all over 2 is -1.5. So we have -1.5 again, another point on the curve. So let's decide to expatiate this zone and put -2 here. So our -1.5 can be on this side. Now the next point again we can have will be 0 all over 3. It will be 0 on the x zone and 3 on the y. So we have x being equals to 0 and y equals to 3. The point is here. And lastly, our minimum turning point, because we know that a is greater than 0. Since a is greater than 0, so then we are going to have a minimum turning point on this graph. So we see that our y at minimum turning point, the value first of the symmetry, the value of the symmetry corresponds to -5 all over 4, and -5 all over 4 is -1 and 1/4. -1 and 1/4 is -1.25. So -1.25 can be at this zone here. So the line of symmetry will be as such. We'll be getting as such. Now, lastly, we are going to have the point of y there. The point of y at the line of symmetry will be -1 all over 8. So I put -1 over 8 can be a very small value between 0 and 1. So it can be somewhere here like this. So my graph will end up be as such. This is the method of quadratics. Now, if you want to use the method of tables, in the method of tables, you need to ask yourself some questions when you are drawing it. You put x at the first zone, you put f prime of x, which is a gradient function, and you put f of x or y. These are the three things that you have to put. Now, you have to ask yourself the first question: what is the domain of x? When you want to draw the second way, we know that you have the equation y is equals to 2x cubed plus 5x plus 3. In this equation here, there is no place where x does not exist. So everywhere it's going to exist. So the domain of x here will exclude infinity, and it goes up to plus infinity, excluding it. So this is the domain of x here. So you can write already on your graph that domain of x will be from -infinity to positive infinity. Now you come back again, you have this same curve. The curve is y 2x cubed plus 5x plus 3. So the gradient function f prime of x will be, I differentiate, I multiply, is x squared, please, squared. So x squared, I multiply here, I have 4x, I subtract here by 1, plus I have here 5. This is the gradient function. And now, I have to know that in the gradient function, I need to find the number of turning points. I have the gradient function. Now, the turning point, at turning point, At turning point, f prime of x will be equal to 0, so it implies that 4x plus 5 is equal to 0. So at the turning point, x is equal to negative 5 all over 4. So this is the corresponding point where the x is the turning point. The turning point at x. Now, if we continue, we see that we have again y. If we substitute now in this equation, we are going to have the same value we initially had there. So into negative 5 all over 4 squared plus 5 into negative 5 all over 4 plus 3. All this is going to boil down to negative 1 all over 8. So I'll come and still come to this side and do as such negative 5 all over 4 x. So negative infinity, I can put a certain value of 0 between here, and I say that 0 corresponds to which value? 0 on the x-axis is going to correspond, as we have already seen here, we said 0 on x-axis is going to correspond to a 3 on the y-axis. So I'm going to point down to a certain value of 3 here. And I will say again that negative 5 all over 4 is going to correspond to negative 1 all over 8. Negative 1 over 8, is it above or below 3? Is going to be below 3. So I'm going to plot again another point here. Now, I'm going to ask myself several questions from the differentiation. So here will be negative 1 all over 8. Again, in order for me to find the value of y when it tends toward infinity here, I have to find the limit as x tends toward negative infinity of my function. The function is this. I see that if I put a negative here and I square it, and I put a negative here again, this negative, the infinity squared plus an infinity only, is going to be more positive. So I think that is going to give a positive infinity as such. And if I try to find the limit as x tends to positive infinity, you see that of this, if I put infinity here and I add with a certain positive infinity, I'm still going to have a positive infinity. So here it tends toward positive infinity. Now, I can try now to find the intervals, the f prime of x between the different intervals. I know that f prime of x is equal to 4x plus 5. If I put a negative value like negative 3, which is behind in this interval, negative 3, I put negative 3 here, is 4 into negative 3 plus 5 is going to give a negative value. So this is negative, so it implies that here is going to descend as such. Now, in this interval, I have a between this interval is negative 5.4 and negative and 0. Between negative 5.4, negative 5.5 is negative 1 and a half and 1/4. So there is negative 1 here. I place negative 1 here, and here I have a positive value.